After the teaser, let's dive a bit deeper and look what nChips actually does. I'll walk through the architecture, the user interface, and a bit the philosophy behind it, because all these are tightly connected to each other. Most of the screen is dedicated to the 3D view. This is essentially a live model of the CNC machine where the relevant components are represented. The grey line with the dot is the current spindle position. The orange box shows the volume in which the spindle can move. It's defined by the max travel settings of the controller and the G53 coordinates. The grid object shows the orientation and 0 of the active coordinate system. Now if we select an object that can move the spindle, let's take the probe. The controls pop up and the spindle shows the motion vectors. It's all color coded. Means the orange button is going to move the spindle in the orange direction. That's pretty handy, especially on a vertical milling machine design where the table moves and the spindle is fixed. Because there it can be pretty confusing if you're talking direction of the table or direction of the spindle relative to the table. It's the same concept as every object that can move the spindle. Like the free probe is essentially a normal probe, you can just define a custom direction to probe, or the manual node. Here the vectors on the spindle also got the length of the move, so you see where the move will end, or if it's within the machine limits or not. If I hit it once, the spindle moves to the expected end position. Now I can already see it's not gonna work a second time. If I try hitting it again, it also refuses to work because it's being checked against the machine limits before execution. This avoids ending up in an alarm state and need to reset the machine. You might have noticed there's no classical menu bar on the top here. It's hidden behind the spacebar. If you hit a spacebar, a menu pops up, and now you could use your mouse to click on the items. Or you just use the key in front of each function. It's actually a keyboard shortcut system based on the key sequence. The cool thing is, after using a function a couple of times, it becomes muscle memory, and it's extremely fast. That's heavily inspired by a plugin for NeoVim called WitchKey. You don't need to memorize anything, but you can, and you will. If you hit the spacebar twice, there's a fuzzy object selector popping up. At this point, I'm actually not sure if this is a little bit too opinionated. If I should add a normal menu bar on the top or not, I will see. In the panel on the left are the controls for the active CNC object, with the DRO, override, a job control with run, pause, stop. Stop is actually a macro. Gabel doesn't have a stop function, so it sends a feed hold. Wait for the machine to stop, then flushes all the buffer, resets and unlocks the machine. So you can also use it to get the machine out of an alarm state or to unlock it. The rest is pretty standard: spindle, jog controls, of course with keyboard shortcuts. If you hold on Ctrl and Shift, you can use Vim motion keys or the cursor keys and page up and down. And 1, 2, 3, 4 for setting the increment. And down here is a feedback console with everything sent to the controller and coming back. Only the status reports are filtered out. This would get way too messy. And at the bottom of it is a command line. You can click on it or you can activate it by hitting the tab key, and then you can use cursor up and down to flip through your previous commands. You might have noticed I've been referring to the active CNC object. That's intentional. The architecture allows multiple CNC machines to exist in the same scene. Only one can be active at a time. Active means it's connected to the controls here on the left and it's visible in the viewport. So you're not limited to a single machine, or in the future a single type of machine. I'm not sure how often that's needed in practice, but the architecture supports it, so I'm not gonna artificially restrict it, and it's kind of cool. Let me demonstrate it by plugging in an Arduino that is running Gabel to mock a CNC machine. This CNC object here is connected to my machine in the shop. Now I create a second one and connect it locally to the Arduino. Now they're both living in the same scene. I could run a job on one while setting up the other, or run a job on both at the same time. This here also explains the server-client architecture. When I connect it locally to the Arduino, a server starts in the background that talks to the CNC, while this here is just the client talking to the server. That's why I can sit here in the warm office while being connected to the CNC in my shop. There, the server is running on a Pi Zero inside the machine's cabinet. This architecture comes with a few advantages. First of all, I don't need to expose any USB cable to the electromagnetic noise of the spindle. Second, what's happening here with the client and the execution of the job are isolated. Let me show you what I meant with isolated. I quickly open some G-code. Make this a bit bigger. And I delete the first two toolpasses because they're drilling cycles and they're very boring to watch. So now let's take a look at this. I also delete the spindle command to keep it a bit more quiet in here. And I run the job. What's happening now is that the G-code is being sent to the server. It's like 5,000 lines and it's happening pretty fast. But what I can do now, I can close the program and the job keeps running. I can even close the laptop. Or I can open it again. Start the software again. And everything is pretty much like it was before. Of course the G-code is missing. But we can fix that. Here we go. But most important, I got full control again. For example, I can change the feed overrides. I can pause it. I can unpause it. Or I can stop the job.